Okay, welcome back students. So we're doing question 8 of the 2020 sample paper. An equilateral triangle XYZ has sides of length 6 centimeters. Okay, let's double check. Well, they're not to scale anyway right now, it doesn't matter. Write down the size of the angle at Y from X to Y to Z. From X to Y to Z. Well, they're all the same size. Okay, they're all going to be the sum of the triangles in the angles in a triangle add up to 180, and they're all the same. So obviously the calculation will be 180 over 3, which is 60 degrees. Okay, so that's the property of an equilateral triangle. Work out the length of the perimeter of the triangle. Okay, so we know that each side is 6, so the perimeter will be 6 plus 6 plus 6. Obviously I just want to write down some maths here. So we will say the length of line segment XY plus, you don't have to write this down at all, you can just even write down 18 as your answer, but if you get it wrong, of course, so that wouldn't be great. So I just want to put in some extra maths. Line segment XY, the distance from X to Y plus distance from Y to Z plus distance from Z to X is equal to 3 times the distance from X to Y, because they're all the same, is equal to 3 times 6, which is equal to 18 centimeters. Okay. Maria plays a game using the triangle. She flips a coin and moves the counter in the direction X, Y, Z. I don't know what that means yet. I'll have to try and figure it out. Does it mean go that direction? Because that's a pointer. She moves the counter in the direction as shown in the diagram below. Oh, she flips a coin and moves the counter in the direction. Oh, as shown in the diagram below. Okay, if she gets ahead, she moves the counter 6 centimeters. Okay, I get it now. It should be in the sense it's counterclockwise or clockwise. So she's got her coin or some sort of a toy or something on the triangle. She flips and moves the counter. Yeah, she has a counter. She flips the coin and moves the counter. Where does it say deck counter? Where is this? The introduction of the counter? Without, it's not a proper introduction. I'm just trying to make sense. I gather that she's got a counter and she's moving around like this. If she gets heads, she moves the counter 6 centimeters. If she gets tails, she moves 12 centimeters. Okay, so heads gets her 6 centimeter clockwise, and tails gets her 12 centimeters also clockwise. Okay. At the start of the game, the counter is at point X, so it took an awful lot of reading to actually come to an understanding, because I'm down here by now, and now I understand that her counter is here, and if she gets a head, she goes to here, and if she gets a tail, she goes to here. If she was here and she gets a head, she goes to here. If she gets a tail, she goes to here. Okay, I get it. She gets tails on each of the first 4 flips of the coin. We can model that out. 1, 2, 3, 4. Which point is the counter at after the first 4 flips of the coin? Well, I just did it. 1, 2, 3, 4. The answer is Y. Now, explanation. 4 sides is the same as, moving 4 sides is the same as 1 side movement. So 1, 2, 3, 4 is the same as, see, the first 3 cancel that, so it's actually clock maths. Okay, I gather this would happen. So we're over here now. Jody makes, I gathered it was going to go on, I was thinking it was going to go on to an extra question. Jody makes a solid shape using equilateral triangles as faces. It has E edges and F faces. So remember now, this is a solid. They should not be using the word shape. Solid and shape don't go together, which is strange because this is a sample paper. It should have been a solid figure. And yeah, these cannot go together. That's called an oxymoron. They should not be together. Using an equilateral triangle as faces. Okay, so basically you have a three-dimensional sort of thing and there's an equilateral triangle at the bottom and at three of the sides. There's 4 faces in total on this yoke. Just like in a cube, you have 8 faces. Okay, on this fella you have 8 faces, and on this thing you have 4 faces. And we could start using the rest of it, but I think they're going to give us the maths. We could start modeling it and make it an investigation, but look, we're in an exam, so we have to drive on. It has E edges and F faces. You know what? We could actually answer the question without any algebra. So it'd be nice to do that, because that's making an assumption or making a guess at our answer. It might even be the right answer. So we'd have 3 faces here, and we'd have 1, 2, 3 faces here. So there'll actually be 6 faces, and I'd say that edges. Sorry, 6 edges. And I bet you that's going to be our answer. 4 faces, 6 edges. Where E and F are natural numbers for Jody's shape, and then they give us this a simultaneous equation. So we have worked out 4 faces and 6 edges independently of using the algebra and this given information they gave us. Okay, so let's go ahead and we can do a simultaneous equation or a substitution. I think we'll go with a simultaneous equation first because it's what you know, but substitution is another alternative which I might do over here. Okay, so first I want to clear the fractions on the top, so I'm going to times 5 the top. Okay, and times 5 will clear the denominator. This will be 5 over 5 will cancel, and I'll get 8f. Okay, I'll times 5 the minus e, giving me minus 5e. So like this is like this now. And I'm timesing 5 all the way across both sides. So coming to the far side, I'm getting 10. Okay, now 8f can go, 3f at least can go here, and the 2e can transcribe back. So it becomes minus 2e equals 0. Okay, now I can get the top and the bottom to cancel to make them 10, and let's make them opposites. So I'll times 2 the top, and I'll times minus 5 the bottom. So timesing 2 the top, I get 16f minus 10e equals 20, and times minus 5 now, so 5 is 15, negative 15. Minus by minus is plus 10e, and minus 5 by 0 is 0. Okay, now they cancel by addition, eliminate by addition. Oh yeah, write that because that's your partial credit anyway. Eliminate by addition is your method. And you're getting f. Oh, okay. Oh, because I made it the simplest shape in my mind, but it could have been much more complicated. Like a soccer ball has loads and loads of pentagons on the edge of it. Yeah, okay. So f equals 20. So she's loads of those faces. Fine, my assumption was wrong, but that doesn't matter. I can drive on with this. And now I can use substitution. And maybe the simplest place to substitute f would be here. Okay, so 320s equals 2e, 60 equals 2e, e equals 30. Okay, and that's our substitution finished, and we have our two answers. Now we're going to just do it a different way called, so this was elimination. Now we're going to use substitution as a method. So basically what that means is you can replace E or F. We can make F the subject of the formula, so we can use one as a substitution equation. Now, having said that, 3F is awkward with 8F, because it would have been very handy if this was 2F or 4F. Okay, because I'd have to divide this by 3 and multiply then by 8. This is going to be a fraction one way or the other. So we'll go with the fraction E equals 3F over 2. So that's a substitution. So every time I see E up here, I'm going to put 3F over 2. I'm going to get 8F over 5 the first term, minus 3F over 2 the second term, equals 2. Now, to clear the 5 and the 2, I can multiply across by 10. Okay, and which is multiplying across by 2 for this one, and by 5 for this one. And there I am with my F equals 20 again. Okay. I'm not sure that this is better at all. I'd say this is better in this case because the fractions. So, but then they will come out again with the rest of that with E equals 20. Okay, so subbing is a method that we will see from time to time, and we're supposed to do it. Very important, and there are some cases in leaving certs, but there are some cases where substitution is the only way to do it. And when it isn't linear, when there's x squareds involved, or 1 over x is involved and x's, you have to use subbing. As always, students, I will see you in the next one.